In this video, we will calculate the probability of dependent events. As an experiment, Sally randomly picks out a card of a deck of 52 cards without replacing the first card, and then she picks a second. If the first card is a spade, what's the probability that the second card is also a spade? Stop. Let's answer that question, because this is kind of a two-parter. Okay, so we're asked about the probability of a spade if we already know that our first draw was a spade. Okay, so we want the probability that we draw a spade. So this is on the first. In a deck of cards, our spade is one of our denominations, which there's 4 of those in a deck of cards, and there's 13 of each. So there are 13, whoa, sorry about that, 13 spades in a deck of cards out of those 52 cards. So that's the probability that we draw a spade on the first one. What's the probability that we draw a second spade? So we were told that we do keep that card, right? It says without replacing. So we now know there's 51 left. And there's also 12 spades. So 51 total cards, and there's 12 spades left. So we have the probability that the first one's a spade, we have the probability that the second one's a spade, and we want both of those things to happen. So the probability in total that we draw a spade first and draw a spade second is equal to multiplying these two probabilities together, and we can only multiply them because our second probability accounted for the information that we already know. So if you would like to refer to this definition of dependent events, that we can multiply the two probabilities of E1 and E2, I think that should be an E1, only if the second probability accounts for that event. It's the probability of event 2 after event 1. And we did account for event 1 already. So now we can multiply them together, and we get, with some simplification, 1 over 17. So that was part 1 of this problem. Part 2 asks, what is the probability that the second card is a club? So we still have the first card being a spade, but now we're asked what's the probability the second card is a club. So let's calculate that. So this would look like the probability first card is a spade and second card is a club. Okay, we already know the probability that the first card is a spade is 13 out of 52. And then the probability that the second card is a club, well, we kept that first card, so there's still only 51 cards remaining. But since we haven't drawn a club yet, there's still 13 of those left. So with some simplification, we end up multiplying these fractions and we get 13 over 204, or you could give that as a rounded decimal answer. Let's try the next one, still using a deck of cards and practicing this dependent events probability. So the example says, you pick a card out of a deck of 52 cards, and without replacing the first card, so we're in the same situation still, we pick a second card. What's the probability that the second card you picked is a heart if the first card you picked is a heart? So here we want the probability, we'll write it the same way, that the first is a heart and the second is a heart. So this is similar to one that we just did. So I recommend that you pause the video and you try to work through these probabilities yourself and play the video when you want to see the solution. So the probability that the first card is a heart, remember a heart is one of those denominations, so there's 13 hearts out of 52. And considering that we already did that and we kept that heart, what's the probability we draw another heart? Well, there's only 12 hearts left and there's only 51 cards left. So this is similar to that spade and another spade. And so we simplify this, and just like above, we get 1/17. Let's try one more that's just slightly different. Let's say you have 20 friends and you want to divide them into random teams of 5. So you mix up 20 colored straws with 5 of each color: red, yellow, blue, and green. If each friend picks a straw, what's the probability that the first 3 friends will be on the same team? Okay, so we want to know that first straw, second straw, third straw are all the same color. We did not specify a color for that first straw. So let's keep that in mind. That changes how we calculate this probability slightly. Okay, so really we want the probability of some color, we'll call it color 1, on the first pick. We want that same color 1 on the second pick. And we want that same color 1, whatever that color is, on the third pick. So how are we going to do that? We know there's going to be those 3 probabilities. As long as they account for the information prior, we can multiply them. For the first probability, we just want the probability that color 1 is chosen on the first try. What the heck is color 1? Well, we didn't specify what color 1 was. So it can be any of the colors. It can be any of the straws. There's 20 straw choices, and we can choose any 20 of them. So really the probability is 1 right there on that first pick, because that's going to help us determine what color we go off of. But we don't want to limit ourselves on that first choice. So then we'll say this determines the color. So now we have the color dwindled down, right? Maybe we picked a red straw. So now that we have chosen one of those red straws, right? There's those 1, 2, 3, 4, 5 red straws. We chose one of those. There's only 4 red straws remaining out of the 19. Okay, we pick one of those. There's only 3 red straws remaining out of the 18. When we multiply those together, there is a 0.035 probability that the first 3 straws are the same color. Pretty small probability.